Hello, in this video, I would like to go over using the nearest neighbor algorithm and the sorted edges algorithm to somehow concoct a good Hamilton surface based on the weighted graph, weighted six connected graphs that we have on the screen here. So, as I have on here, we're going to start at this vertex. So, the smallest weight that we can possibly find on this list here is going to use this edge here with an 8 that connects it down to E. And that had a weight of 8. And let me just draw that in on here so we can just see where we're going. Down to that vertex E. Then from E, the next one that we could go to that's the smallest weight is going to be to this vertex F with that weight of 11. So now we add 11 to this total weight. And then from F, the smallest weight that we could go to goes up now from there to this vertex of C. Drawing in on here so we can see it. C, and we're adding 7 to this one. And from that point, the smallest goes over here to the right to B with that weight of just 1. And then from B, right, the smallest that we could go to technically is 10, but because we didn't list every vertex in the circuit, we can't just go back to A just yet. We have to. We're kind of forced into going over to D now. And the only way that can be accomplished is going down this edge, which has a weight of 15. And then we have to go now from that vertex, we listed all the other ones, and go back to A. And that one also has a weight of 15. So the sum of all those, the 8, 11, 7, 1, 15, and 15, should give us a value of 57. So the circuit that the Hamilton circuit that provides us is A, E, F, C, D, D, A for this nearest neighbor algorithm. Now, by contrast, we could go and do the sorted edges algorithm. So, doing that for this one, again, we are starting at the vertex. But we do need to list out all of the weights for the sorted edges. Just bear with me as I list all these out. There's a lot of edges. 1, 7, 8, 9, 10, 11, 12, 2, 13, 2, 14, 3, 15, and it's 1. All right. So with that being, we're going to take the 1. Right, that's the smallest one here. It's not connected to the A, but it is the smallest one that's here, and we should definitely make sure that we have to take it. We're going to use that one. The next smallest one here of a 7. That does not create any three-way intersections since we only have one edge ready. So we want this one connecting C to F. The next one after that, there's an 8 there, which again, we want to use for this. It connects A to E, and again, has no three-way intersection. So now once we get to that point, right, this next one here is a 9, which actually does connect to the A, which is always a good thing. And based upon what we already have, it connects down to F up to C that we already drew, over to B, which we also already have. So that's starting to complete the portion of the circuit. So we definitely want that one. So this edge here with a weight of 9. And then from there, we just have, well, we still need to get to D and then find the connection over to E as well. So continuing on with this list, if we go with the 10 after this, it's going to connect up to the B over here on the right-hand side. And that doesn't help us in completing the circuit, so we can't use that one. The 11 down here on the bottom creates a three-way intersection. The 12 would help us go from this F over to D. But the only problem with that, though, is since we already have the F on here, that creates a three-way intersection, so we can't use that despite the fact that it includes G. The 13, 113 connects B and F, which creates a subcircuit. This other 13 connects C and D, which creates another three-way intersection of C. 14 connects B and F, B and E, excuse me, over here. That creates a subcircuit again. But the other 14 we have is F, E, and D. So we want only one of these 14. It gives us that connection to D, which we need. So in order for us to have this circuit be completed, in order for this circuit here to be completed, we would need then for us to go from that value of that we just got with the vertex of D. The only way we could possibly complete the circuit then would be to connect D to B, which has that weight, one of the weights of 15. So this one. So the circuit that this uses starts at A, we would then go down to F, C, B, D, E, and then back to A. So we would be adding the weights of 1, 7, 8, 9, 14, and 15. Adding those all up gives us a total weight there of 54. So by contrast with the nearest neighbor algorithm we did before, this one gives a slightly different answer due to the different type of algorithm that we're using. Let me know if any of you have any questions or concerns. Thanks.